In this video, I will show you how to write the standard form equation of a conic section like a circle, an ellipse, a parabola, or a hyperbola. So problem number 5. We have to be really careful about this problem. I actually made a mistake with this and had to re-recording the video now because usually the vertices and the co-vertices are right on the lines. And I'm asking you to find the focus is the thing that we normally have to find. But this problem is backwards. The vertices are still right on the lines, so that's normal. But what's not normal is the co-vertices. Notice how the co-vertices are a little bit between the lines. It's not right on the lines. When I first did this problem, I didn't notice that, and I just started counting to left and right. But that's not a mistake. So if you see this on the test, it's meant to be between the lines. That means the co-vertices are your radicals this time. So just watch out for that. So obviously we have a vertical ellipse. So as we set up for the equation of a vertical ellipse, we know that we're going to do x minus h squared over something plus, well, I guess we know that this will be b squared because it's vertical, so the long way will be the y direction. So then we'll have y minus k squared over a squared is equal to 1. This is not the answer, but this is the model that we're shooting for as we form the equation of this ellipse. The first thing you should always start with is the center, because that gives you all of the numerators. So that's pretty obvious. The center is going to be this point right here at negative 3, comma 1. So the center is at negative 3, comma 1. So that's my h and my k. So let me go ahead and just update that. So I'll be doing the opposite of each of these. So I will have x plus 3 here, and I will have y minus 1 there. Now we need our a squared and our b squared. The a value is the distance from the center to a vertex. So this is the a value that I'm tracing in red right now. That's the a value. So that part is normal. Let's see, I'm going from 1 to 9. So the a value then is 8, which means that a squared is 64. Notice that this is vertical. It's in the y direction. So of course I'm going to put the 64 in the denominator of the y term. It just makes sense. So the 64 is going to go right here. But now I need to find b squared. This is what I messed up before. I just started counting my way over, not realizing that it's between the lines. Can anybody tell me, because this is actually a live class, internet. That's unusual for me. Can anyone tell me how can I find b squared when it's between the lines like this?
I did, I took the a, and I did the equation a squared minus b squared equals c squared.
She did the equation c squared is equal to a squared minus b squared. Okay, so we're looking for the b value, so that means we must have a and c. Of course, we just found a squared, so that was 64. Okay, this is what we usually do finding the foci, so that it's just a little bit backwards. The c value. They're giving us the c value because we know that the c value is simply the distance from the center to a focus. So this segment that I'm highlighting, the arrow that I just put in green, that's the c value. So what is the c value?
36.
Right, so c squared is 36 because I hear you saying that c is 6. We're going from 1 to 7. So c squared is 36. So we can use that to find b squared. So 36 is equal to 64 minus b squared. Adding b squared to both sides and subtracting 36 gives me b squared is equal to 64 minus 36. Okay. What's 64 minus 36 real quick? 28. So b squared is 28. Okay. The 28 is the thing that I want for the denominator. So as far as the denominator goes, don't take the square root, just write down the 28 because that is the b squared. Now understand that the b value is the distance from the center to a co-vertex. Okay, so that red arrow I just drew, this is the b value. So if I take the square root of this, then that will give me the b value, which I will need to label the co-vertices. So taking the square root of both sides, b is equal to the square root of 28. 28 is 4 times 7, so b is 2 radical 7. Notice that we cannot use the decimal form. All right, on your last quiz, some of you guys were giving me decimals for stuff like this. You cannot. You have to use the 2 radical 7. Okay, so when you're dealing with a decimal like this, you have to look at the center. Actually, first of all, let's take care of the coordinate that is easy. The y value of these co-vertices, switching to purple. So this is a co-vertex, and this is a co-vertex. The y value is obviously 1. It's right on the line at 1. So we know the y value is 1, so we're going to have something, comma 1, and something, comma 1. So get that y value out of the way. It's easy. The part that takes a little bit more thought is the x value. For the x value, you have to think of yourself as starting from the center. The x value of the center is -3. So we're starting at -3, and we're moving to the left or to the right. If we move to the left, we're subtracting. Okay, so I'm doing -3 minus something. -3 minus 2 radical 7, because that's the b value. So the left co-vertex is -3 minus 2 radical 7. Similarly, the co-vertex on the right is going to be starting at -3, so -3 plus 2 radical 7 because we're going to the right. So -3 plus 2 radical 7. And that's it for problem number 5. For number 6, they want us to write the standard form equation for this parabola. The standard form equation comes in 2 flavors, 2 slightly different versions. One is for vertical parabolas, and the other one is for horizontal parabolas like these. So if the parabola is vertical, the x term will be squared. If the parabola is horizontal, the y term will be squared. Since this parabola is vertical, it's opening upward, I'm going to choose the model that has x squared. And so that model looks like this. It goes x minus h squared is equal to 4p times y minus k. Okay, so this is the model that we use if it opens up or down. If we ever had a parabola that opened to the left or the right, we would put the y minus k squared instead, and the x minus h would be over here. Anyway, the h and the k are the coordinates of the vertex, as they always are. So notice that the coordinates of the vertex here are -4, 1. So I'm just going to do the opposite of these as I write the equation. So this will be x plus 4 squared, because of the -4, is equal to 4p times, and I'll put y minus 1. Now, I cannot leave this as 4p though. I need to figure out what the value of 4p is. And of course for that, I need to know what P is. Well, the P value is going to be the distance from the vertex to the focus. Now they didn't give us the focus, but what they did give us is the directrix. Do you see it down here? See this dotted line? This is the directrix. This is useful because the focus should be the same distance in the opposite direction. So let's see. What is this distance right here? Well, it's 4 down and 1 up. So that's a total distance of 5. So if I do that same distance above the vertex, that's where the focus should be. So the focus should be right here. Boom. Because it's got to be 5 up, because this is 5 down. And really that 5, that positive 5, that is the P value that we need. So P is 5. If P is equal to 5, then 4P must equal 20. I'm just multiplying both sides by 4. So 4P is 20. So I'm going to go ahead and erase the 4P and put 20 in its place. By the way, P can be negative. It was positive this time because from the vertex to the focus, I'm going up. But imagine a parabola that was facing downward and had a focus that was below the vertex. In this case, P would be a negative number, like -3 or something like that. So please understand that P can be negative. Anyway, this is the standard form equation. We're done. They asked us for one additional thing, the coordinates of the focus. Okay, so I don't need this right now. The coordinates of the focus are -4, 6. So that's it for number 6. For number 7, they want us to write the standard form equation of this hyperbola. All right, let me scroll up so you can see more of it. The hyperbola in 2 branches of blue, all right? These 2 blue curves together form the hyperbola. These dotted lines are the asymptotes, all right? The green dots are the vertices. The orange dots are the co-vertices. Okay, anyway, the format for the equation of a hyperbola depends on whether it's vertical, like this one, or some hyperbolas are horizontal, like this one. When the hyperbola is horizontal, the x squared term goes first. Okay, when the hyperbola is vertical, like this one, the y squared term goes first. So the y squared term has to be first. So this will be the model. We're going to do y minus k squared over something, and I'll say more about this in a moment, and then minus x minus h squared over something, and this will always equal 1 in standard form. Now, these denominators are a squared and b squared. Okay, a squared and b squared. So we need to find a and b. The h and the k are the center of the hyperbola, so we need to start there and figure out what the center is. So the center will be right where these asymptotes meet. It's right halfway between the vertices and co-vertices, so this is the center. Notice that the center has coordinates 1, 3. Okay, that's my h and my k. So I can go ahead and fill in that part of the equation right now. All right, so the y-coordinate is going to go in the y part of the equation. So this is going to be y minus 3. The x-coordinate will go in the x part of the equation. So it will be x minus 1. All right, so I have that. Now, the a value is the distance from the center to a vertex. Okay, so from the center to a vertex, this is the a value I've illustrated now. Well, this is from 3, I'm looking at the y value here. This is from 3 to 9. So that means that my a value is 6. That means that a squared is 36. Okay, so I'm going to put a 36 right here. By the way, notice that this a value is vertical. That's the y direction. So it makes sense that I'm going to put this 36 in the denominator of the y term. Okay, now we need the b squared. The b value is the distance from the center to a covertex. This distance right here is the b value. So that's 1, 2, 3, 4. So my b value is 4. Wait. This is in between the lines. Let me slow down. This b value is not 4. I was being too hasty. This covertex is between the lines. This might be a square root or something. So we don't know what this is. We definitely cannot assume that this is 3.5 or something like that. Instead, what we have to do is use the c value that we also have. Okay, so look at this. They gave us a focus, which will give us indirectly the c value. So look at the green line that I'm drawing right now. This is the c value, because the c value is the distance from the center to the focus. So what is this c value? Well, again, I'm looking at the y value. So I'm going from 3 to 10. That is a c value of 7, which means that c squared is equal to 49. So here's what I can do to find the b value, or b squared. We can use the relationship that for a hyperbola, c squared is equal to a squared plus b squared. For an ellipse, this is a minus, but for a hyperbola, it's a plus. We know that c squared is 49, and we know that a squared is 36. We don't know b squared. But we can subtract 36 from both sides. That will give us b squared of 13. I don't need to take the square root because it's b squared that I wanted. So that tells me that I will have 13 right here. That's my b squared. Notice that my b value is horizontal. That's the x direction. So it makes sense that I will put my b squared, my 13, in the denominator of the x term. All that's left is the equation for the asymptotes. Now understand this. The equation for the asymptotes will always be y minus k is equal to plus or minus m times x minus h. This is just the point slope form of a linear equation, where m is the slope and the point, well, I'm using the center as my point. That's why I'm using h and k. But it could have been any point, but the center is the one point that's on both lines. So that's why I'm going to use it. But the way it works, and did I say m is the slope? M is the slope. So look, this is also y minus k right here. And this is also x minus h. So I don't need to go back to the beginning. I can just look at my equation, and I know that inside the parentheses here, that's my y minus k. So I just put y minus 3. This x minus h is the x minus 1 that's in standard form. So all I really need is the slope, the plus or minus m. To find the slope of the asymptotes that I'm going to put right here, we normally use the rectangle that we draw passing through the vertices and the co-vertices, and we find the rise and run using that rectangle. Now, they have not drawn the rectangle for us, but we can go ahead and draw it in if we're very careful. So just go ahead and draw yourself a rectangle, all right, as a dotted line passing through the vertices and the co-vertices. Understand that the asymptotes will pass right through the corner of the rectangle. So that's why I'm sort of stopping the line at the asymptotes, because this is where it's going to turn and go in the other direction. Okay, so this is the rectangle that we need to use. So we need to know, starting from the center, what is the rise and the run. Think of it like this. I'm going to go from the center to this corner. Okay, I think I'm going to change to orange for a minute. Okay, so I need to do the rise and the run. So how far up is this? And how far over is it? That's the rise and the run. Now, hopefully you'll recognize that the rise and the run are just the A value and the B value. Okay, this vertical part, the rise, that's the A value that we found a minute ago. So that part is simple. This is 6. Okay, that's the A value. Now the run is a little bit more tricky. Remember that the co-vertex here is between the lines. We never actually found what this distance is. It's something between 3 and 4, but we don't know exactly what it is. But whatever it is, this is the B value. We do know that. This is the B value. So we found B squared a minute ago. B squared is 13. If we take the square root of both sides, that should give us the B value. So B is equal to the square root of 13. Okay, so this is the B value. Hold on, it looks like the square root of 3. Let me do better. All right, the B value is the square root of 13. So that means the run is the square root of 13. Okay, because that's the same distance from the center to the co-vertex is the same distance here from the vertex to this corner. So rise over run is going to be 6 over radical 13. It's just the A value over the B value. So that's what we need. So the slope is 6 over radical 13. And that's it for problem number 7. All right, for number 8, we are asked to find the standard form equation of this ellipse. Now, the shape of an ellipse equation is like this. X minus h squared over something plus y minus k squared over something is equal to 1. I will talk about the denominators in a moment. But the h and the k are the coordinates of the center of the ellipse. You can tell that the center is right here. Let me just double check. 1, 2, 3, 4. 1, 2, 3, 4. So this is the center. Okay, this has coordinates 1, comma, negative 3. So that is my h and my k. So I can go ahead and put those values into the equation right now. Because of the minuses in the formula, it's sort of like I will have the opposite of these two numbers. So I will have x minus 1, and then I will have y plus 3. So the signs change as you put them into the equation. So now all we need to do is find out what the denominators are going to be. The denominators are a squared and b squared. But we have to be careful which one is a squared and which one is b squared, because the a value is the distance from the center to a vertex. Here's a vertex over here. So the distance from the center to a vertex, okay, like that, that is my a value. So that's 3, 4, 5. So a is 5, and then a squared is 25. So 25 is going to be one of these two denominators, but which one is it going to be? Well, notice that this a value is horizontal. It's in the x direction. So this 25 will definitely be the denominator of the x term. Now let's find the b value. The b value is the distance from the center to a covertex. This is a covertex. So this is my b value, this distance. That is 3. So my b value is 3, which means that b squared is 9. Notice that this b value is vertical. It's in the y direction. So this 9 is going to go in the denominator of the y term. So this is the standard form equation of the ellipse. They are also asking for the eccentricity. The eccentricity is the c value divided by the a value. So I already have the a value, but I don't have the c value, so I need to find that. I know that for an ellipse, c squared is equal to a squared minus b squared. So that means c squared is going to equal 25 minus 9. So that means c squared. Well, you know what? Why am I doing these calculations? I feel silly. Here's why I feel silly. The c value is the distance from the center to a focus. Okay, so this is the c value right here, from the center to the focus. So I don't need to sit here and calculate it all out. So the c value is 1, 2, 3, 4. Okay, so c over a then is going to be 4 over 5. All right, I already knew that the a value was 5, so it's just 4 over 5. So that's all they wanted for number 8. For problem number 9, they want us to find the standard form equation of this hyperbola. The model for the equation of a hyperbola works like this. Well, actually, we have to pay attention to whether it's a horizontal hyperbola like this one, or is it a vertical hyperbola like this one. If it's horizontal, then the x term goes first. So I would have x minus h squared minus y minus k squared over something is equal to 1. Okay, so since this is horizontal, the x squared goes first. If I ever had a vertical hyperbola, the y minus k squared would go first. All right, but that's not what's happening. So this is the model. The h and the k are the center of the ellipse. So it's easy to see that the center is right here. The coordinates of this point are 5, negative 2. So these values are the h and the k, so I'm going to substitute them into the formula now. When I put them into the formula, they will basically change signs. So I will have x minus 5 and y plus 2. So now all we need is the a squared and the b squared. So the a squared, well, I should say the a value is the distance from the center to a vertex. So this is my a value right here. So that's 2. Because a is 2, a squared is 4. So this will be one of my denominators. But which one? Well, notice that this a value is horizontal. It's in the x direction. So this 4 will go in the denominator of the x term. Now, let's talk about the b value. The b value is the distance from the center to a co-vertex. That is 3. So that tells me that b is equal to 3. That means b squared is equal to 9. So 9 is going to be the other denominator. But pay attention to this. Notice that this 3 is vertical. It's in the y direction. So of course this 9 will be the denominator of the y term. Okay? Notice that for ellipses, a squared is always bigger. But for hyperbolas, that doesn't have to be true. Okay, now, the asymptotes. The asymptotes of the hyperbola will be the diagonals of this, they will pass through the diagonals of this rectangle. All right, so here are the asymptotes shown as dotted lines. The equation of the asymptotes will always look like this. Y minus k is equal to plus or minus m times x minus h. This is really just the point slope equation of a line, where m is the slope, and I'm substituting a point in here. Now, I'm writing h and k because the point that I'm always going to use for this will be the center of the hyperbola. So that's why I'm using h and k. But in general, you could use any point you want. But the center is the one point that's on both asymptotes. So that's why I'm picking it. It makes everything very simple, though, because the x minus h and the y minus k are already present in the standard form equation. So in other words, the y minus k is the y plus 2 that's in the parentheses right here. So I can just sort of copy off of my standard form equation and copy the y plus 2. And the x minus h, that's this. So I could just put x minus 5 right now, like straight out of that equation. So all I really need that's new is the slope, the m. And that's just rise over run. So if I look at the center and I look at the corner of the rectangle, and I just ask myself, what's the rise and what's the run? Okay, so I'm sort of looking at it this way. I'm going up and then I'm going over. So the rise is 3 and the run is 2. All right, it's really the b value and the a value. So it's 3 over 2. Okay, that's it for the equation of the asymptote. And that's it for number 9. For number 10, we need to write the standard form equation of this parabola. Now notice this is a vertical parabola because it's opening down. And when the parabola is vertical, we know that we are dealing with the version of the equation that has the x squared. So x minus h squared is equal to 4p times y minus k not squared. This is the model that we use for vertical parabolas. If we have a parabola that is sideways, meaning that it's opening to the left or it's opening to the right, then these are reversed and we'll have the y minus k squared instead. So we've got the model. Now the h and the k are the coordinates of the vertex. So the coordinates of the vertex are 4, comma, negative 3. So we have 4, comma, negative 3. So the equation will become x minus 4, all right, there's my 4, squared, is equal to 4p times y plus 3. Notice how I did the opposite of this and the opposite of that. So all we really need is the p-value. Now the p-value is the distance from the vertex to the focus. Now I don't know where the focus is, but I know it will be floating around somewhere, like maybe it's here, maybe it's here, maybe it's here. The focus is somewhere along this area. But I don't want to guess at it. But they didn't give me the focus. So what do I do? Well, they did give me the directrix. And the directrix and the focus are the same distance from the vertex, but in opposite directions. So notice that the directrix, all right, let's count these squares and see how far away the directrix is. So let's see, that's 1, 2, 3, 4, 5, 6. So the directrix is up 6. That means that the focus must be down 6. So if I go down 6, 1, 2, 3, 4, 5, 6. Okay, this must be the focus right here. Okay, and this distance is the p-value, including whether or not it's positive or negative. If I go up 6, that's a positive 6. But if I go down 6, that's a negative 6. So p is equal to negative 6. Now, if I were to take this negative 6 and substitute it in right there, then that would mean I have 4 times negative 6, 4p. Well, that is negative 24. So that is what actually belongs in this spot of the equation. Negative 24. So this is the standard form equation for the parabola. And they also want the coordinates of the focus, which we found to be right here. So this is the point 4, comma, negative 9. So that's the focus, 4, comma, negative 9. And that is all they wanted for problem number 10. Alright guys, that's going to do it for this video. Go ahead and click here in the red apple to watch the next video. Click in the green apple to subscribe, or click the yellow apple for the full playlist.